Hello again, my fellow Jeti users. Welcome back to my workshop for another Harry's Little Jeti Clinic videos. And in this video, we're going to be looking at the solution to a very specific and unusual problem. But when I tried implementing it in other things, I realized you could actually use it in a lot of places. And it's strange it hasn't occurred to me before, because quite a long time ago I made a video called Smooth Demixing, which was really for coupled aileron and rudder, so that as you moved the rudder it took out the coupling and allowed you to get full travel. What's going on with this one? Well, a friend of mine has a quite fascinating scale glider called an IS5 Kachka. I think the original was a one-off. If you'd like to see what it looks like, and I recommend you do, Google for IS-5 glider and you'll find it. It was just a little pod fuselage. It didn't have the rear fuselage or a tailplane, but it did have canards at the front of the pod. And out on the wingtips are the fins, each one with a rudder. And my friend, I think, finds it quite, shall we say, challenging to fly. It's not the best behaved aircraft, and he's been flying it, I think, on multiplex and solved all the programming fairly straightforward, as you would expect with multiplex, who have fantastic software. I still regard the multiplex 4000 as the gold standard that everything aspires to. Anyway, he's converting it over to Jeti. And I've got the setup here. We've got our rudder brake servo for the left fin, rudder brake servo for the right fin. You see, in order to get air braking, you move both rudders outwards. Okay. Now, and when you're operating a rudder, as rudder, you only want the inboard rudder to move outwards. And that way you get a bit of braking as well. You don't want the outside of the turn rudder to move at all. Well, all that is very easy to do if you accept this, that your servos are at their mid position and you get the brake only in one half of the travel, and you would get rudder for only half the travel. I know I've got both servos moving, but it's very easy just to make one servo alone move, so you get just the outward bit of the travel. But then you've lost half the travel of the servo. Well, yeah, so why not get the full travel of the servo? That way you can get more travel on the surface, or you can connect in a hole on the servo and get more force, linear force from the torque that's available, or you can connect out a hole at the horn on the surface, which in effect has the same effect because the surface can then generate less backward force on the push rod. And of course, because slop is a fixed angle in the gearbox, going in a hole at the servo means less linear travel in the slop, so it's a good thing all around. So that would mean that, for instance, the servos are like this, and you change the push rod, so your rudder is now sitting absolutely straight. That way, when you want to use the brake, you get the full travel of the servo. That's a good thing. And up here, you would get the full travel of the servo. That's left rudder. Here's right rudder. Gives you lots of options. Travel, more force for the given amount of torque, less slop. Problem my friend had was he couldn't get this to work in Jeti, and he tried all sorts of ways of function curves and offsets, but whatever he did, starting from a position like this, if he applied full brake, he could only get half travel like that, and if he applied the rudder, he'd still only get half travel like that. And he could not work out a way to fix it. Could I help? And I must admit, I spent a lot of time puzzling over this one, because I too was trying things like function curves and fixed offsets and such like. And the issue all the time was you then couldn't recover anything more than half of the servo's travel. You couldn't get any more than go from one end to middle, because you were now trying to add on 200% of travel to the offset at what would actually be the rudder's neutral point. And I was thinking and thinking and thinking about it, and all of a sudden the light went on. It's very easy actually to do. First of all, let's have a look. What we've got is function assignment. There's our rudder on the P3 stick. Here's our brake on the P4 stick. Lovely. And what we'll do is mix the brake to the rudder at 100%. No need for any offsets or weird function curves. It's the brake to rudder mix that's pushing the servos into the offset. So there, with rudder at middle and P4, which is our brake, also at mid stick, of course the servos are at neutral. If I push the P4 stick to its end, no brake required, there is our offset. Lovely. So of course now we've got the full travel available for the brake. What about the rudder? Well, if we now moved the rudder, we would still get just half travel by half stick. Why is that? Well, at the moment, the brake stick is applying 100% travel in this direction. If I now move the rudder by full stick, the rudder is trying to apply 100% travel in the opposite direction. And so 100 that way, 100 that way brings you back to 0. So you're only going to get mid-travel. Meanwhile, this one would have 100% brake applied, and then the rudder be trying to apply another 100%. So you'd quickly hit the 125% travel limit, and so on. And the same would happen, obviously, at full brake. You'd have the brake mixer trying to apply 100 in one direction. Then you start moving the rudder, it's trying to apply 100 in the other direction. So one servo only gets back to the midpoint and the other quickly hits the 125 limit. How do we do that? Well, switch off the brake mixing. Yeah, go in here. There's a switch. You can switch the brake mixing off. But then it would simply be a bang on, bang off. What we want to do is progressively switch the mixing of the brake off as we're moving the rudder stick. And how do we do that? Well, we need to create a function, and I've called it the RD mix for rudder demixer. And if you like to have a look at it, I'll try and put a link at the end of this video, or just search YouTube for Jeti smooth demixing, as in D-mix. But it's very important here. We assign it to the P3. It's just standard P3 control assignment. Now the clever bit is in its function curve, the rudder demix. There's no servo applied to this, by the way. It's just sitting there as a function. So let's have a look at its curve. We've changed it to a 3-point. We've brought this point up to 0, the midpoint up to 100, and that end point down here, down to there. So now as we move the rudder stick, you can see it goes from all the way on to 0. So from plus 100 down to 0. And now we can use that rudder demixer as the switch. Here we are. So it's not the rudder stick, it's actually that demix function. Let's clear that out and show you how to get it. So you press plus and you come down to functions. And there it is, the rudder demixer. So select that, say OK. Look at the master value of the mix. The rudder stick is in the middle, so the switch is fully on. As I move the rudder stick, it progressively switches off until it's at 0. So it's not a bang on, bang off switch, it's a progressive mixing. And that's what solves the whole thing. Why? Because let's say, as we are here, the brake is fully forward, so the brake mix is fully on, and the switch from the rudder demixer is fully on. Okay, so we've got 100% travel from the brake, no travel from the rudder, switch fully on. There we go. What happens if I now start applying rudder? I'll apply full rudder. Notice that only this servo moves, and that's because full rudder, the mix is now gone off. So 100% of the rudder travel has been able to happen, pardon me, and at the other side has also moved to 100% of the rudder travel. But there's no brake anymore, so that's what we've got. Let's go to half rudder. At around half rudder, there we are, the mix is now 50% applied. Yeah, so we've got half of the brake mix, so that's going to be 50% brake, and I'm putting in half rudder, which is pulling it back to the midpoint. 50% that way, 50% that way, gives you the midpoint. Whereas over at this side, the brake mix is now only 50%, but the rudder travel is giving 50%. So it holds it up there. So 50 plus 50, whereas here 50 minus 50. Okay, let's put it to there. Let's bring the brake to the midpoint. So there's mid-brake, so both rudders are canted outwards a little bit. And let's apply rudder. There we go. What's happened is we've got 50% brake, but with full rudder on, the mixer's come down to 0. It's off. So all we're getting now is rudder. And that gives us our job. So no brake, servos round there, rudder works, left rudder works that side only. Go to full brake, so both rudders are canted outwards. If I go left rudder, the left one stays at fully out, and the right one comes all the way back at full rudder to being back in. It's the rudder's level, servos out there. Half brake, both work. In other words, if I go left rudder, this one comes out even further, and the right rudder goes back to neutral. And you can use this form of demixing all over the place. I say my original video showed how to do it with a coupled aileron to rudder, but I've tried it in the butterfly screen, where the switch is, again, this sort of demixer, inverted V curve, and with flight modes, setting the flaps with aileron to flap mixing, and you can remove the aileron to flap mixing whilst your flaps are in position. It's not a clever one to use in the butterfly menu though, because of course, being the input switch, as soon as you move the ailerons, it messes up your elevator tuning or any of the other tuning values you've got in there. So it has limited value in that. But it's a handy little thing for using offsets on your things like your flapperons if you want, with brakes in them and all sorts of other things. So have fun with this.